I would like to talk about the method of solving simultaneous equations, and I am using a node voltage analysis problem for doing that. So I have done the problem a little bit. So this is the circuit here, and there is a current source, there are few resistances, and I have assigned, I want to solve this one using node voltage method. So I have assigned I have identified three nodes, this node 1, node 2 and node 3 there, and what I have done is I have assigned three node voltages to those nodes, and this one is the ground node. So for node 1, which is this one, this one, I have written the current KCL, Kirchhoff's current law. So on the left hand side I have written the leaving currents, and on the right hand side the entering current. So this one is the entering current, which is the current source, and the leaving current V1 over R2 is this one, and then V1 minus V2 over R3 is this one. So for any node, that's the normal way, or the standard way, or usual practice rather, of writing the KCL equations in the node voltage method. So I have done that, and then I have rearranged the equation here. So V1 over so what I have tried to do here is I have identified the coefficients of V1 and V2 like that, and this is the I on the right hand side. Similarly, I have written the for node 2, and again for node 2. Now for node 2, this current is the leaving current, three leaving currents there, and that's why V2 minus V1, because always the currents are leaving, and then V2 over R2, and then I have, this is the leaving, all three leaving currents there, and then I have rearranged the equation as the coefficients of each node, so like that. Similarly, finally for node 3, this one, there are two leaving currents here, this one and this one, and so I have written the currents there, and then again this one also I have rearranged with the coefficients. So now in order to solve, so there are three unknowns, V1, V2 and V3, and I have three simultaneous equations, so they are solvable. So I will use the determinant method to solve it. So what I will do, I will write the solution for each of them. So basically this is V1, and there will be 3 per 3 determinant, this one. So basically the determinants will be the constants. So for the first one, so 1 over R2 plus R3. So this is the coefficient in the first column. What I am doing is writing the coefficient of V1, the coefficients for V1. So for the second equation, the coefficients of V1 is 1 over R3, and that is a negative sign. And for the third one, the coefficient of V1 for this one is 0. Similarly, for in the second row, I will write the coefficients of V2. For the first one, the coefficient of V2 is minus 1 over R3, and for the second one, the coefficient of V2 is sum of these three. So basically 1 over R3 plus 1 over R4 plus 1 over R5, and the third one, the coefficient of V2 is negative 1 over R5, like that. And finally the coefficients of V3 in the third row. So in the first equation the coefficient was 0, in the second equation the coefficient was minus 1 over R5, and in the third equation the coefficient is like that, so 1 over R5 plus 1 over R6. So these are the three rows, and we can see a pattern actually if we look back in the circuit. So for V1, the coefficients are actually the resistances that are connected to it and the inverse sum of those, but R1 is not included because there is no voltage source here. There was already a current source, so the current source has gone to the right hand side, so that's why we have excluded the R1 here. And the negative 1 is coming only for the adjacent node, which is V2, and the connecting resistance is coming as inverse and a negative sign. So this is exactly what's happening. Similarly for V2, the three resistances will be 1 over R3, 1 over R4, 1 over R5, because these three are connected to it. So that is the coefficient for V2, and there are two adjacent nodes for V2, V1 and V3. So V1 is connected by R3, so that's why the coefficient of V1 is negative 1 over R3, as we can see here, and the negative of the coefficient of V3 is negative 1 over R5, because V2 is connected with V3 by R5. So there is a pattern. Actually we can write these equations, in fact we can write the determinant solution directly from just by observation, but we will do few more to get there. Finally, for the third equation we can see where now I am writing in terms of the columns, so sorry, the rows. So for the third equation, the coefficient of V2 was 0, because if we look here, the V3 is connected, the adjacent node is only V2, V1 is not adjacent, so the coefficient is 0. And then the resistances connected to V3 are R5 and R6, so those two are coming as inverse sum, and the adjacent node is V2 only, and that one is connected with V3 by R5, so 1 over R5 is coming as a negative, and the coefficient of V2, so that's there. So we have this thing in the denominator, and the numerator what we will have is, since we are trying to do V1, the second row and the third row will be, second column and the third column will remain the same, so that will be the same whatever it is, like the denominator, but the first column will be just the right hand side. So I will write, let me just finish this one first, R over 5 and then 1 over R5 plus 1 over R6, and the first so this one was 0 here, and the first column will be the right hand side, so basically I 0 0, because those were the right hand sides, the three right hand side. For the first equation the right hand side was I, the second and third was 0, so that is the solution for V1. Now for V2 it will be exactly the same, the denominator will exactly be the same, so I will just write maybe just delta, which is this one, if this one I call delta, and on the numerator it will be exactly the same, only the second column now will be I0 and 0, so the right hand side, and similarly for V3 the rest will be the same, so I am not writing. And for the third one again, for V3 actually, sorry, for V3 it will be here, so two determinants, in the denominator it will again be delta, and the third column, since V3 we are dealing with, it will be I3, and the rest two columns will be the same. So this is how we can solve it, and we can directly write this V1, V2, V3 just by looking at the circuit if we can write them properly, but even not, we can write them from the KCL looking at the coefficients. So yeah, that's the video just about solving simultaneous equations, and I will do a few examples.